Okay, I'm going to talk through question number 3 in your free response packet. This is actually from the 2002 Form B AP Calculus AB test, question number 2. So it is a calculator question, and there's been a lot of questions on different parts, so I'm just going to talk through the whole thing. If you don't want the whole thing, you can scroll through and find what you want. I'll try to keep it under 15 minutes, but I am going to go through compared to the answer choices. One at a time, or to the AP rubric, sorry. Let's start with part A. So I'm assuming you've already read the question stem. If not, pause the video and read the question. Part A is asking, is the amount of pollutant increasing at time t equals 9? Why or why not? So I want to know if the amount is increasing. So you might be attracted to thinking about actually P of t, which is giving you the number of gallons and the amount. But the interesting part is you only have the rate function. But let's think about if we want to know if a function is increasing or decreasing, because that's essentially what the question is asking. How does the derivative help me determine that? So at this point, I'm not even thinking about this problem. I'm thinking, what does the derivative tell me about a function? And the derivative, in particular, the sign of the derivative tells me if a function is increasing or decreasing. Okay, maybe you remember this, where we say if the derivative is positive, then the function is increasing, and if the derivative is negative, then the function is decreasing. That's the kind of thinking. I'm not going to need to do all of that, but that's the kind of thinking I'm doing right now. So I really want to know what is the derivative doing at time equals 9. So I'm seeking p prime at 9, and then I'm going to make my decision from that. So calculator question, good thing because that's an ugly function. So if you haven't already done so, I wouldn't actually do this on your home screen. I would type your function p prime into y1 because if you need to use it, you're probably going to need to use it more than once. So go ahead and type that function into y1. Then go to your home screen and find the derivative. It's been a while because we've been doing integrals. I want you to calculate the derivative at time equals 9. So I'm going to give you a minute to do that. Pause the video, and then we'll meet back together and see what you got. Okay, hopefully you got the same thing I did. P prime of 9 equals negative 0.6464, maybe rounded to 3 decimal places. That's not really my answer, so I just went ahead and did 4, but you could have totally stopped it right there. My answer is going to be a yes or no. So now I've got to figure out, is my answer yes or no? Is the amount of pollutant increasing? I'm recognizing that my rate is a negative rate, less than 0, and therefore my answer is going to be no. The amount of pollutant is not increasing. Let's be specific. I'm literally rephrasing the question. At time t equals 9 because p prime of 9 is less than 0. Done. So let's take a quick look at the AP free response rubric. I broke it up into parts, so we're just looking at the first part, and here's what they had on their rubric. This was a 1-point question, answer with reason. You needed both to get the point, and it looks pretty much like what we did. I noticed that we didn't actually plug it in. I don't believe that you need to do that. It's not a bad idea in case your answer goes wrong. If you type something in the calculator wrong, but again, this is 1 point, so really not giving you partial credit. As long as you can show what you're doing by doing p prime of 9, you should be good, okay? And notice that they do make that comparison less than 0 for their reasoning. Okay, moving on to part B. For what value of t will the number of gallons of pollutant be at its minimum? Justify your answer. So this question you've seen a few times now, maximum or minimum. Oh, sorry about that. Something just fell. We'll continue. So, how do I find a minimum value? And I know a lot of you, when we saw this a couple days ago, you wanted to be looking at the function p and then be able to use your calculator to find the minimum point, which is great if you have the function p, but sometimes you don't have the function p, and trying to find the function p isn't actually your easiest option. So I'm going to start with what I have, which is the derivative, and say, how can the derivative allow me to find a minimum? And I'm thinking about this number line test, that if my derivative's going from negative to positive, then my function is decreasing and increasing, and that actually gives me a really solid way to be able to find a minimum value. So the first thing I need to do is find the critical points and see where those occur. So critical points are where I set my derivative equal to 0. So I'm going to start by saying, and sometimes I just like to make a little note of what I'm doing. So I'm about to find when p prime of t equals 0. So I'm going to set 1 minus 3e to the negative 0.2 radical t equal to 0. And we could technically go to our calculator at this point, just for the sake of practice, more or less. This is something that, even though this is on the calculator section, you will be asked to do on the non-calculator section. They love exponential functions. So let's see what we can do with this. So I'm going to say 1 is equal to 3e to the negative 0.2 radical t, and try to isolate my t, which means isolate my exponential. Divide by 3, and I get 1/3 equals e to the negative 0.2 radical t. And then at this point, I've got e to a power. I want to get the variables in the power, and I want to get that out of the power. So my option is to, my only option at this point is to convert this to an exponential equation. Or sorry, it's in an exponential equation. Convert it to a log equation. Remember, those go hand in hand, so I can go from one to the other. And so I'm going to take the natural log of both sides. That allows me to then take this power property of logs that can come out front. So I'm going to end up with here that the natural log of 1/3 is equal to negative 0.2 radical t times the natural log of e. And the natural log of e is really just 1, because e to the first power is equal to e. So that really goes away. I don't even need to worry about that. And at this point then, I'm dividing by negative 0.2. That cancels out, and I've got natural log of 1/3 divided by negative 0.2 equals radical t. And to get t by itself, I'm squaring both sides to cancel out the radical. So I have t equals natural log of 1/3 divided by negative 0.2 squared is my exact answer. Now, when you look at the free response rubric, when we look at that in a second, the answer rubric, you're going to notice that they did some simplification here. I don't believe it's necessary because they didn't say give an exact answer, so I'm assuming that our general rule of 3 decimal places is going to be fine. So I'm typing that in the calculator and getting 30.174 for that answer as my t value. Okay, just for a quick talk through of what they're doing in the answer rubric, they're separating this into natural log of 1 minus natural log of 3. That's a property of logs. Natural log of 1 is 0, so really it's a negative natural log of 3 dividing by a negative 0.2 is going to be a positive, and 0.2 is 1 over 5, so it becomes 5 natural log of 3. Okay, it's all properties of logs, but this is literally equal to 5 natural log of 3. Quantity squared. Again, they didn't say give a simplified exact answer, so I think we're fine with the 30.174. But I'm not actually done with the question, so let's figure out what the question was. So I have 30.174 is now my number right here. And I need to verify that this is actually correct, because this was just kind of my thinking at the very beginning of, oh, to get a minimum. And notice we only had one critical point. Okay, we could have ended up with more than one critical point, so pretty good idea I have at this point that that is the minimum, but I need to do a quick justification. So I would be graphing this function that you already typed in your calculator. Time is 30, so give yourself a rough idea of what you need for your window. I need to go past 30, so maybe I go 0 to 50, and then for y values, this is the derivative, and I'm looking for the derivative signs. So it really doesn't matter. Negative 10 to positive 10 is fine. Keep it like that. You just need to see if it's crossing the axis. If it is indeed below your axis and above your axis, and that should be happening. So take a minute, pause the video, graph it, and make sure you actually do get this. And then figure out what are you going to write for your answer, because remember, this is not worth anything on the AP test. So how do you put that into words? Okay, pause the video and join me in a minute and let's check what we did. Okay, so we're looking at the free response rubric, and again, I told you to see what you could say to justify, and I think you'll notice the first part is exactly what we did. You get a point for setting p prime of t equal to 0. That's a great point right there, because even if you solved it wrong, so I know this was a calculator one, but assume it, just think about the scenario if it's not a calculator question, you mess up the solving, you get a point just for showing, okay, I knew I needed to find a critical point, which is awesome. If you get that value, second point, and then justification, right here is what you should have had. P prime is negative for t is less than, and you could have used 30.174 here is fine. And I like the way they include 0, so they're saying that whole part. Remember, 0 is just our beginning part. You might have just said this. Good idea to include both. And then positive for t is greater than 30.174. Therefore, there's a minimum at t equals 30.174, or 5 natural log of 3 quantity squared. Okay, hopefully that makes sense. Moving to part C, but take a minute to process if you need to. C, is the lake safe when the number of gallons of pollutant is at its minimum? Justify your answer. Okay, so this question is sort of a sneaky question because this is asking for an amount, but then there's a follow-up part to it. So if you read between the lines here, the question is really asking how many gallons of pollutant are there when it's its minimum. So they like to do this where they make you use an answer from a previous question. We just found the time value, remember from part B, 30.174 was when the number of gallons of pollutant is a minimum. We know that. So now they're asking us how many gallons of pollutant are there at that point in time. Okay, so this question takes us, this is directly from this chapter of what does integration mean? Why am I jumping to integration? Because I have a rate function and I need to get an amount. So an integral of a rate gives me an amount. Okay, an amount of change, remember, a net difference. So integral of velocity gives me the change in position. Integral of the rate of change of number of gallons per day is going to give me the number of gallons. So if I'm doing integral of p prime, I always like to break this down and justify it for myself with units. P prime is gallons per day. I'm supposed to say gallons. And then my dt is, my time is days, so it's going to be a small change in number of days. And that's giving me number of gallons. So the amount of pollutant in number of gallons. Okay, hopefully you're on board with that concept. So let's actually figure out what in this question do I need to do. So in this particular question, we want to go, remember, at that minimum point. Okay, so the amount, when it says minimum, so I want the amount of, I'm going to use P because I want to figure out the pollutant, the amount of pollutant at that point in time. P at 30.174 is equal to the integral from 0 to 30.174 of my p prime. There's no reason you need to rewrite that function. They've defined it as p prime, so they know if you write that, they're going to know exactly what you're referring to. Okay, now we need to pause here and make sure that's going to give us our answer. Maybe you type that in the calculator, but I'd say even before we type in our calculator, there's a lot of other information in this problem that we haven't used yet, and that might be one reason to pause. The other reason to pause is to remember that an integral gives us the change in the amount. So maybe I should have written that here. The net change in the amount of something from some beginning to some ending point. So in this case, the first 30.174 minutes. Or no, days, sorry, because my time is days. Now, if I want the total amount, did I start with 0 gallons of pollutant in the lake? Because the only way that this is going to give me my actual answer is if my lake started with 0 gallons of pollutant, which could be the case, but in this particular problem, there are 50 gallons of pollutant in the lake at time equals 0. So I need to account for that 50. How am I going to account for that 50? You got it. We're going to add that to the end, or maybe you added it to the beginning. That sounds weird, but maybe you put 50 plus right here, 50 plus. As long as you're putting this dt, you're closing the integral and then showing you're adding the 50. But a lot of people like it the other way, which makes total sense. A student explained a similar question the other day by saying, you know what, I thought about it like I think about velocity and position. And they said, I think of it if I'm trying to find a position. So a position at some point in time, let's say at some point in time B, I have to do they described it as I have to find the initial position. I have to start with that and then figure out how far did I go from A to B. And that's exactly what I'm doing here. So hopefully you can see that this is your initial position, initial amount, and then we're finding the change in the amount. Okay, at this point, go ahead and go to your calculator and see what you get, and then we'll pick back up. Okay, as I start the video again, I do have my answer here of 35.104 is what I got when I typed that in my calculator. I did want to make a quick comment, though, that a really good way to handle this is we should be paying attention and being specific here, and we shouldn't even actually be using this in our calculator. I've showed you how to store values, and I highly, highly, highly recommend that you use that feature. So when you found that minimum amount, remember it was some crazy fraction that we typed in our calculator, we should have stored that. So a common way of noting that is to say let A equal, and then you would have written the exact amount. And maybe you put that fraction, natural log of 1 over 3 divided by negative 0.2 squared equals approximately 30.174. And I would just write out once all the decimals that you get in your calculator to show that you're storing that as A. And then what you could do is you could write this as just an A here and an A there, and you just refer to that. And as long as you have that on your paper, they will understand what you're using when you're referring to A or B or whatever letter you pick for that. Okay? Back to the question. Hopefully we're getting more than 1 point for this because this is taking us a little bit of time, but that's okay. Justify your, we got to figure out, is the lake safe? So the lake is considered safe for the actual question when it contains 40 gallons or less of pollutant. So this is obviously not a hard question to answer mathematically. We got 35.104, and at this point I'm saying that that is less than 40. So yes, the lake is safe. So you're going to write out, I'm not going to take the time to do it right now, that yes, the lake is safe because the number of gallons of pollutant is less than 40. Obviously, the point of this question was to see if you could calculate the number, not to actually determine if you could decide what was less than 40. Okay, let's take a look at the rubric. Okay, we're getting 3 points for this. So 1 point for the integrand. That would be for setting up this and putting your rate function inside and realizing that the integral of the rate is going to give you an amount. 1 point for your limits, and I am interested that they put 30.174. I more commonly see them doing what I proposed as the second option of putting a letter there to represent that minimum point. So I would encourage you to do that, but maybe they would give you full points if you didn't. And then 1 point for the conclusion with reasoning. So I'm not sure, I guess that comes in here, because if you hadn't added the 50, well, you still would have, if you hadn't added 50, you would have ended up with a negative number. So I'm guessing that that figures in here, that you needed to have this statement, and if you didn't have this number correct, you would have missed that third point. Okay, last part. So an investigator uses a tangent line approximation to P of t at t equals 0 as a model for the amount of pollutant in the lake. At what time does this model predict that the lake becomes safe? I love this because this ties back into the first semester concept that we tackled at the very beginning of second semester here. Tangent line approximation. Wow. So don't panic. It's been a while since we've done this, but let's remember what we know about tangent lines. It's a line. So let's go back to Algebra 1 class. And equation of a line, point slope form, I've been telling you all year to use that. Y minus y1 equals m times x minus x1. And then let's just think through this. Time equals 0 is my x value. So time equals 0. is going in for my x. I need to find a y1. That means I need to figure out what my y value is when my x is 0. So let's go with p of t. Okay, so I was about to plug into here, and then I paused because that's p prime of t. That's going to give me my slope, which I also need. So we can go ahead and do that. Then I'm going to go back to my other question and try to figure out p of 0. P prime of t, if I plug a 0 into my power, that's going to give me 0 over all e to the 0 is 1. So 1 minus 3, and I don't know why I'm trying to do this in my head, p prime of 0 ends up being 1 minus 3. You might want to write more on your paper, but for the sake of time, I'm going to suffice to say that's 2. Sorry, negative 2, because it's 1 minus 3. So negative 2 for my slope. And then the other thing that I was trying to figure out was p of 0. So p of 0, I don't have a p function, but that's my initial amount. That's the number of pollutants in the lake at time 0, and they gave that to us. We used that in the last part. That's the 50. So here's my equation. So I've got y minus 50. If I simplify this, negative 2x, and then minus 0, which is y equals negative 2x plus 50. So I know I tell you a lot of times not to solve for y, which you really don't have to, but for the follow-up part, it's going to look better to you if you do. It's doable without it, but it is going to look better because they say at what time t does this model predict that the lake becomes safe? So you're looking for a t, which is my x, my independent variable. You can change it out for t if you want. You're looking for a time value. When the lake becomes safe, so what's our y value when the lake becomes safe? Y is the number of pollutants. It's just we're using a line to estimate it rather than trying to work with our pretty complicated pollutant function. So that would be 40. So they're giving us this 40 gallons is when it becomes safe. So what they're really asking us to do here is, and maybe you're catching on now, figure out when y is 40, what's my x value? So the whole point of a linear approximation is we reduce it to a simple equation to work with, and I think you'll agree with me at this point. Negative 10 equals negative 2x. I don't need my calculator at all for this. And I'm getting x equals 5. Again, my x is time. So the model predicts the lake becomes safe at time equals 5. We should put a unit in there, 5 days. Got my work to justify it. We're ready to look at the rubric. I'm going to pause real quick here, and I am going to go back to one thing that we worked on and just sort of make a connection here, hopefully, for you. We looked at a different way to set up, and it's really just a difference in notation, our linear approximation. So let me just make a quick connection for you here with what we have here and the other way that I showed you to set this up. So the other way that I showed you to set this up was to use the notation that the linear approximation is equal to the initial value. So this is really my y1 that I'm adding to the other side, and I'm just going to call that, we can use p in this case, or f, at some particular value, so I'm using a to represent that, plus my slope is my derivative, f prime at a, times my difference between x and some particular x value. Okay, in this particular problem, we would say that our linear approximation is giving us p at 0 plus p prime at 0 times t minus 0. Sorry, I'm changing out that a to a 0. And that's exactly the same thing. Obviously, we will be plugging in the p prime was a negative 2. This was a 50. And we'd have 50 minus 2 times t minus 0, which changes into 50 minus 2x. Same exact thing that we have there. But maybe you like that way of looking at it better. Maybe you don't. Either one works. Exact same thing. Okay, I think this video might be longer than I had planned, but I do like to talk through all the parts, so hopefully you found it helpful. Let's take a look at the free response rubric, and notice that we get 2 points for this part. So we've got p prime of 0, so they're giving us 1 point for finding the slope of the tangent line, because that is a calculus step, not from second semester. This is from first semester. P prime of 0, -2. And then 1 point for our answers. So they didn't directly give us that. That's including the writing the equation, because the answer itself is solving. That's an algebra step. That usually don't give you points for that. So Lake will be safe when the amount decreases by 10. That's an interesting way of describing it, I guess, because you're starting at 50. So we need to figure out when is the decrease 10 gallons. That's a very interesting way of thinking about it. So maybe they didn't actually, it looks like you could have gotten points for this if you didn't even write the equation. If you figured out that the number of pollutants had to decrease by 10, and if the slope is -2, that's going to take 5 days for that to happen. I would not have come up with that. I would have done exactly what I showed you. But perhaps if you hadn't done that, there's no point in here for writing the actual equation. So good for you if you thought of that, or you could follow through the whole process, because that's exactly what we did. And that'll work every time. Okay, that concludes this fabulous video. Best of luck with the rest of them. Be sure to message me and let me know if you want another video for a free response question. I'm happy to do it.